The two hydrogen sulfide H2S absorbers were 237 feet 4 inches long by 20 feet 5 inches wide and 20 feet high, and each weighed 1,425,730 pounds. When the eventual transport configurations were added, the resulting transport envelopes increased to 345 feet 9 inches long, with a maximum width of 40 feet and a height of 27 feet 11 inches. The total transport weight was 2,548,440 pounds each. Our customer originally planned to store these vessels near the Port of Mobile until such time as the wires along the transport route were raised. Burkhalter suggested that the additional costs associated with multiple roll-on and roll-off operations, as well as potential damage resulting in storing components on the Gulf Coast during hurricane season, would be reduced significantly by locating a storage area near the roll-off site. Our customer agreed, and Burkhalter identified and secured a roll-off location at the nearest suitable barge siding to the Kemper County facility, as well as developed a suitable storage area within 1 mile of the roll-off site for the storage of all vessels. Hurricane Isaac, which hit Mobile in September of 2012, confirmed the wisdom of this approach. Obtaining specific shipping information from the manufacturer on the H2S absorbers prior to their arrival in the USA was an ongoing challenge. Shipping cradle locations, dimensions, weights, and center of gravity information changed multiple times, with each change requiring modifications to the Burkhalter transport vehicle. Burkhalter ultimately developed a bolstered trailer configuration employing new low-profile transport saddles. By the time this concept was accepted by the manufacturer, Burkhalter had less than 10 days to complete the production drawings and fabricate the two transport saddles. The enormous size of the H2S absorbers and the associated transport vehicles presented different critical path issues along the transportation route. For the bridges being crossed, the gross weight of over 2.5 million pounds per H2S absorber was the driving factor. With an overall transport length equivalent to over a football field, the length of the configuration was of critical importance at the 5 90-degree turns encountered. Burkhalter needed to balance the various interior bridge requirements with the area swept out by the huge load when negotiating turns. In the case of secondary roads, maneuvering trailers of this size created specific challenges. When traveling in a straight line, the footprint of each bolstered trailer effectively occupied over 92% of a 98-foot section of highway. During road bends and turns, it became imperative to continuously monitor the trailer location. The 28-foot transport height required all transmission lines along the route to be relocated. Burkhalter coordinated these activities with Southern Company, East Mississippi Electric Power, 4 County Power, AT&T, as well as 3 cable companies and 4 municipalities. However, critical issues remained with high-voltage TVA power lines. The transport route crossed under 161 kilovolt transmission lines at 7 locations along the route. At 4 of these locations, the heights of the lines were well within the 10-foot clearance envelope required. Estimates to raise these lines would result in an 18-month delay to the site construction schedule. Realizing the magnitude of this problem, Burkhalter offered to develop an engineered solution to this issue. Southern Company decided they would attempt to negotiate outages with TVA while at the same time allowing Burkhalter to develop an alternative solution. Our solution was simple in concept. If the wires could not be raised, then we would have to lower the load. Burkhalter developed a plan to hover the vessels under the wires. To accomplish this feat, Burkhalter would design, fabricate, and install special load support mechanisms at the tail, skirt, and trunnion locations on the H2S absorbers. These devices would extend out beyond the diameter of the vessel in order to enable 4 SPM-TE transporters, each outfitted with 2 500-ton hydraulic gantry legs, to be positioned outside of the vessels. After strengthening and widening the road, this system would allow the vessels to be offloaded, lowered, travel under the wires, and then be reloaded onto the transport trailers. Burkhalter completed a feasibility study and pricing proposal for the increased scope of work. However, Southern Company was eventually able to negotiate an outage schedule to de-energize the 161 kilovolt lines instead. But there was a catch. Burkhalter was now required to transport the 2 H2S absorbers in a convoy. Viewed individually, the task of transporting just one H2S absorber over 76 miles of public highways and 9 bridges was certainly daunting. When the job required moving 2 H2S absorbers simultaneously in a convoy, the task became monumental. This would require twice the amount of equipment, including another set of the special low-profile transport saddles and 2 new low-profile bolsters for use on the second trailer configuration. Our customer gave us only 4 weeks to assemble the additional equipment and crews, source and manufacture the additional saddles and bolsters, and coordinate a new plan with Mississippi Department of Transportation. After agreeing upon an appropriate price adjustment, Burkhalter changed direction and agreed to the accelerated schedule. A 76-mile transportation route had been identified by Burkhalter. Key features of the route included 44 miles of 24-foot wide 2-lane state highways, 32 miles of 4-lane roadways, 9 bridges requiring bridge analysis, 1 railroad crossing, several long hills with grades in excess of 10%, and super elevated turns, which, given the immense size of the configurations, stretch the vertical curve capabilities of the transport equipment. As a consequence, Burkhalter developed detailed plans and procedures to ensure that trailer locations within the roadbed, as well as side-to-side trailer heights, were kept within strict limits. All bridges were modeled using finite element analysis, and 8 different trailer configurations were analyzed in order to determine the exact set of load conditions necessary to allow the safe movement over these bridges. Due to the conditions of 7 bridges on U.S. Highway 45, we determined that it would be necessary to travel southbound in the northbound lanes of this highway, a distance of 32 miles. The final configuration employed 2 bolstered 20-line 4-file Goldhofer hydraulic platform trailers under each H2S absorber. Due to the extreme loads imposed by these massive vessels, standard platform trailers did not adequately distribute the trailer loads across the bridge decks. In response, Burkhalter developed a unique extra-wide 4-file configuration of 22 feet 3 inches, as well as designed and fabricated special spacers, steering consoles, and associated longer steering tie bars to provide mechanical steering links to the double-wide trailers. 12 lines of self-propelled PST Goldhofer trailers were incorporated in the rear bolster trailer of each configuration to ensure adequate tractive effort was available to pull these huge loads up the steep grades. Special bridge requirements also necessitated that Burkhalter design a set of 3-line and 3-file belly dollies, which were attached to saddles installed by Burkhalter on the H2S absorbers between the bolster trailers. The belly dollies' location both along the vessel length and width were designed to maximize the effectiveness of the dolly loadings on the bridge. Additionally, 8 wing dollies were required when crossing the longest bridge over the Noxubee River. These wing dollies extended the effective overall width of each transport configuration to a full 40 feet. With the wing and belly dollies, each transporter deployed a staggering 796 tires. Our engineering analysis required different sets of axle lines to be de-energized when crossing bridges. The specific lines varied from bridge to bridge, and detailed plans were developed for each bridge crossing. When traveling down the roadways, the wing dollies were removed and belly dollies were raised to provide increased vertical curve. Once the final trailer configuration and associated details were finalized, Burkhalter developed a comprehensive transportation plan. This plan included an engineered route survey, identification of 4 temporary storage areas, traffic control and emergency response plans, a detailed schedule, an expansive contact list, coordination with law enforcement in 2 counties and 4 municipalities, as well as with MDOT weight enforcement and bridge inspection teams. Communication protocols between Burkhalter and all parties were established for both radio and telephone contacts and distributed to 15 different entities. Special communication protocols were also established with TVA to manage the de-energization of the power lines. In addition to the 2 H2S absorbers, the convoy included police and pilot car escorts, bucket trucks to remove 2 traffic signals, MDOT representatives, emergency repair equipment, backup prime movers, support equipment for the wing dollies, and a motorhome bus to serve as a comfort and warm-up station for the crews. Once in motion, the overall convoy occupied approximately 1 mile of highway. MDOT was concerned with limiting the disruption to local businesses and so required that Burkhalter institute rolling blockades of traffic along US 45, stipulating that opposing traffic be limited to a maximum of 5-mile stretches of highway. To coordinate these activities, Burkhalter contracted a local engineering firm to ensure that all traffic guidelines developed by Burkhalter and approved by MDOT were met. Travel through cities was limited to nighttime only. TVA also required that their outages could only be managed at night and then during specific time windows. Further complicating the timing of the movements was MDOT's requirement to inspect all bridges. In addition, strict rules of travel were established which would not interfere with local and regional football games. As usual, our customer required that the H2S absorbers be delivered immediately. In order to meet these mutually conflicting requirements, Burkhalter developed a minutely detailed schedule which identified exactly when the H2S absorbers could leave their respective temporary storage areas, as well as when each wire and bridge would be crossed. Prior to beginning operations, Burkhalter conducted daily safety meetings with all individuals and agencies involved. After completing the first safety meeting on October 29th, the massive loads pulled out of the initial staging area at 7 p.m. After crossing under the first of the TVA lines, the units arrived at the Brooksville staging area where they would await the next night's movement. Although the second night's move would only be 12 miles, planned delays were encountered at 2 bridge crossings and the 3 remaining TVA power lines before arriving at the route's longest bridge over the Noxubee River. The first absorber was transported over the bridge and staged south of the river, allowing daytime bridge inspection. Burkhalter redeployed wing dollies and transported the remaining H2S absorber over the Noxubee River before delivering both H2S absorbers to the 3rd storage area at Sugar Lock, Mississippi. At this point in the route, MDOT required individual transportation of the H2S absorbers. Due to rain and planned football delays, it was November 4th when travel began on the longest stage of the route for the first absorber. 5 bridges and the highest and longest grades were encountered on this section, which also crossed the railroad, where vertical curve and the narrow location of the crossing gates all required careful execution. The first H2S absorber arrived at the final staging area in DeKalb, Mississippi at around 1:30 a.m. on November 5th. Burkhalter's team of transportation professionals conducted the final leg of the journey, once again overcoming long high grades, super elevated turns, and the tightest turn along the route, before delivery of the first H2S absorber to the plant site on the morning of November 7th. Transportation of the second H2S absorber resumed, following the same route and procedures as the first vessel. The experience learned on the first movement allowed the crews to make slightly better time with the second H2S absorber on this, the most grueling leg of the journey. The final unit was delivered to the construction site in early morning of November 9th, as planned and without incident. Due to the diligence, communication, professionalism, and technical expertise of Burkhalter, the event was completely successful and without incident. This was truly history in the making. Tommy Thames, MDOT Director. All aspects of the job were under the direct care, custody, and control of Burkhalter Rigging. Burkhalter delivered both vessels safely and on time with no injuries, delays, or property damage. Obstacles overcome. Identified, secured, and operated barge roll-off and storage locations until utility wires could be raised. Worked with MDOT to develop third-party engineering processes and certification, as well as coordinating for the inspection of all bridges along the route. Designed, fabricated, and tested special transport saddles and trailer bolsters. Developed procedures to negotiate 161 kilovolt high-voltage transmission lines. Negotiated 45 miles of secondary roads, with trailers occupying over 92% of the roadway. Negotiated grades in excess of 10%. Conducted the majority of the operational travel time at night during cold weather. Transported over a 76-mile route, the two largest loads ever transported over the public highways in the United States. Innovation. Designed, fabricated, and tested extra-wide Goldhofer platform trailers, 750-ton low-profile transport saddles, 750-ton low-profile transport bolsters, saddles and transfer beams for special belly dollies, 4-file 40-foot wide wing dollies, combination PST and push-pull trucks to pull 10% grades. 1,420 engineering hours were expended in conducting the work. 7,158 man-hours were expended in completing the project, which came in on time, under budget, and was profitable for Burkhalter Rigging.